This video will provide an introduction to Lab 2. You can read the description of the lab on Canvas. It's posted there. And I just want to clarify some different things. It's quite a bit of stuff we're going to go over in this lab. So first of all, you'll do the pre-lab stuff. This you should have, you can either bring up MathCAD and show it to the SA or TA that you have these different plots done on MathCAD, or you can just grab screenshots and print them out, or post them in a Word doc, something like that, and show them to the SA or TA that way. There's also a video that you can look at if you have the electronic copy and click on this link. So there are a couple of videos on MathCAD that show you how to do the square wave. And anyways, so in the lab you'll go ahead and work on these first few things, which I think are pretty straightforward. And so it starts to get a little more complicated with 3. So I will say that we had some LabVIEW files set up, but at this point it looks like we're not going to be able to use LabVIEW because the lab computers are running Linux, so we're still working on a solution for that. So basically you will set up this RC circuit right here, and you'll be measuring the voltage across the capacitor, and we'll figure out how we'll have you actually gather that data and plot it. So you may remember this slide from class in terms of what to expect. So in this case there's a square wave here, so it goes from 0 volts, square wave goes up to 5 volts, and the capacitor, of course, if you remember that for capacitors you can't have step changes or instant changes of voltages across them. You can't have a step change in the amount of current going into them, and the way they act is that initially they're just like a short circuit. So if you suddenly change the voltage, the current will flow through it until the voltage builds up, and the flow will stop at this point. So you can see that's what happens here, right? This is down at 0 volts. Suddenly the square wave goes up, and the charge has to build up until the voltage gradually increases over the capacitor. So that's what you'll be able to see here on the oscilloscope. As the volt goes on and off, you'll be able to see what kind of waveform you get. So in this next step, you'll supply voltage to your DC motor, 6 volts, 8 volts, 10 volts, and 12 volts, and record the no-load current, and then also stall the motor. And you want to do that test very quickly. You don't want to leave it in stalled condition too long because you can damage the motor. And then you'll be able to calculate the terminal resistance. So just as an example, so in other words, for the different motor voltages, you'll determine the current at no load and then also at stall. And of course, when you stall the motor, it's basically a resistor at that point, and you can calculate the terminal resistance. In the next step, you'll attach a VEX shaft encoder to the motor, and you can hook the VEX encoder up to your Arduino board, and let's see, you can go to the library manager and download this encoder shown right here to be able to use that to measure pulses. On your worksheet here, it shows that you can then fill in the motor voltages from 3 volts to 12, and then the corresponding motor speed. You'll also want to get a screenshot of the encoder signals with a motor running at 12 volts and answer the questions about that. So I'll have to stop here and pick up with the next video.